today, as I mentioned already, we have UMATI and data ecosystems. And I'm very happy that we have Mark Schmidt as a speaker today. As you can see, he is the director of UMATI certification. And actually, he is in the VDMA for quite some while. And he was there when we started the topic of OPC UA. So he really has some information on first hand, and he already worked with OPC UA before he was here in the VDMA. So I'm happy that we really have an expert speaking today. And with this, I would like to give to you, Mark, and please tell us about what is UMATI and data ecosystems.
Yeah, thank you very much, Heiko, for the short introduction. So I think we will go in with the current situation in manufacturing, go a bit back. UMATI is a major initiative dedicated to the dissemination and establishment of OPC UA companion specification, but what is behind it? So about 8 years ago, VDMA members noticed a problematic situation in mechanical engineering industry. Each machine had different interfaces, spoke different languages, which meant that the semantics varied. This meant that it was extremely difficult to integrate new machines into existing IT landscapes or merge machines from different manufacturers into a new green field or a new green environment. However, the main problem was not to establishing connectivity, as there's no competition and every manufacturer is only interested in connection their machines. So rather, this connectivity led to the question, what infrastructure should be purchased to connect and operate these machines efficiently? The future challenges here are there's a clear competition among platform manufacturers. The business model of offering platforms as a service assumes that interconnectivity between machines already exists. In the future, it's like that the major competition will take place in the area of software as a service. This is also one of the assumptions behind initiatives such as the EU Data Act, for example. Software as a services require platforms to be available as a service, which turn requires comprehensive connectivity. So the key is to create this connectivity to pave the way for future, and platforms must be able to not only allow collect data, but also transform it into actionable information that creates values for users. So the solution to this complex problem is to develop standardized interfaces based on OPC UA. UMATI plays a crucial role here by supporting and spread of OPC UA, and in particular the companion specifications. This standardization promotes interoperability, leading to seamless integration of new machines. This is not only facilitates the integration of new machines into existing systems, but also the collaboration between different manufacturers and suppliers, which increase the efficiency of the entire value chain. So OPC UA defines how communication takes place, while the companion specifications define what is communicated. Both are an integral part of OPC UA and should not be seen as separate elements. When both aspects are implemented, semantic interoperability is created, enabling the true plug and play. UMATI ensures that implementations are standardized and consistent worldwide, creating a global community. This community promotes the exchange of knowledge and best practices, which in turn contributes to the further development and optimization of the standards. Yeah, now we come to the UMATI initiative. UMATI is an acronym for Universal Machine Technology Interface and aims to revolutionize the mechanical engineering industry through standardized interfaces. The initiative ensures that machines and systems from different manufacturers can communicate seamlessly with each other. And this is achieved through the development and promotion of OPC UA companion specifications, which define specific requirements and data types for different categories of machines. UMATI is a very young but dynamic initiative that already has over 300 partners, and it's growing steadily. UMATI is founded in 2019 and officially transformed into initiative form in 2021. And UMATI has since seen impressive membership growth. This strong expansion shows the immense interest and importance of this initiative for the industry. Partners and members come from various sectors of the engineering industry, from large multinational to small and medium-sized companies, all with the common goal of improving interoperability in the industry. So UMATI is based in 3 central pillars. One is community, infrastructure, and marketing. With the community pillar, we have hackathons and plus quests, which are organized to promote collaboration and the exchange of best practices. An example is last year we had a user group meeting where users shared their experience and presented best practices from the companies such as BMW or Deutsche Bahn. Then in terms of marketing, UMATI supports its trade associations at the VDMA and VDW at trade fairs and maintains a strong social media presence. However, infrastructure is the heart of UMATI. The online data space and the well-known dashboard enable companies to connect their machines and display data via OPC UA companion specifications. All these tools and applications are available for free on GitHub, including OPC UA clients and servers, and also the dashboard application. These tools provide a platform for developers, for engineers to implement and test solutions quickly and efficiently. So the aim is to increase the spread and acceptance of OPC UA companion specifications. Originally, the VDMA focused on the machine manufacturers, of course, who are working on their companion specifications. But what is missing? So actually, we don't have user groups at the VDMA. The UMATI initiative makes this possible to address them directly and offer them to a platform on which they can exchange ideas. Working groups, for example, those like related to the automotive industry, and software user groups are example for our initiative. Involving users in the development process of the companion specification ensures that the standards and are relevant to practice and are user-friendly. So how does it exactly work? UMATI supports and endorsed specific companion specification, especially those which are developed in cooperation with the VDMA and VDW. UMATI integrates everything into a common framework, including the dashboard application and the data space. And the communication takes place as far as possible via OPC UA standards, even if some aspects such as a orchestration server are not covered, of course. It's very important to say that UMATI does not develop by its own standards, but it implements all existing standards from VDW and VDMA. The strategy ensures UMATI can act as a neutral platform that integrates and promotes the best available technologies and standards. Then we have OPC UA, the shortest crash course. So OPC UA is an international standard published in 2008. Its main advantages are open source, integrated security mechanisms, support for pub/sub and client-server connections, the ability to create semantic machine descriptions, and so on. So these features makes OPC UA scalable and globally widespread. The standard is designed to be suitable for smaller devices with limited resources, as well as for complex systems in large industrial plants. OPC UA consists of two layers, the transport layer and the information layer. The transport layer, of course, uses internet protocols for data transmission and offers various connection options such as client-server and pub/sub. Pub/sub, of course, is actually more relevant for the data transfer into the cloud and the field exchange. Yeah, so the information layer describes how information are structured and communicated. So this layered model enables the creation of specific companion specifications for different machine types, but also vendor-specific extensions on top. This flexibility allows OPC UA to be used in existing infrastructures as well as in new innovative applications. So then let's move to federated data spaces. First of all, the question, why federated data spaces? So federated data spaces aim to preserve the data sovereignty of the original data owner, while at the same time allowing third parties to use and analyze the data. The concept promotes open and democratic collaboration in which all participants have a say. This enables transparent and trustworthy data processing that takes into account the interest of both data owners and data users in this case. Federated data spaces support a certain of a fair and competitive market to promoting innovation and new business models. How does a federated data space differ from the traditional platform designs? One could argue that traditional platforms is also a data space. However, the main difference is that in classic platform designs, services can be adapted and optimized specifically for this platform. If I knew exactly what hardware I'm working on and what IPA calls I can make, I can optimize my service for this specific. The disadvantage here, however, is that my service only runs on this specific framework. The network usually follows a typical star topology, where many data providers and consumers are connected to a central data sink. And the data storage is often provided by the platform provider, which is often part of their business model by taking over the data management. And this gives them the control over the data and allows them to offer additional services based on the storage data. So the difference to federated data room, a federated data room differs in that the application development is not tailored to a specific hardware and therefore cannot be optimized for it. Data exchange is therefore somewhat more complex as a network architecture is, in which federated services are at the center. So these services are much smaller in the scope and those offered by a classic platform design. Federated services included basic functionalities such as a central registry, which serves as a phone book, for example, where I can find the address of the participants, and a central identity provider, which ensures that the participant who claimed to be him is actually the one. So such basic functionalities are provided centrally. However, as soon as a connection is established between these two participants, the data exchange is directly between them and not longer via the federated services. This has advantage in terms of latency and data exchange speed, of course. And another advantage is that the data remains with the producer, which guarantees data sovereignty. There is no need to store data centrally unless this is especially requested. This concept allows flexible and controlled data management by the respective data owners. A practical example. Service implementation in federated data space. How does a service in a data space, on a federated data space, look like? So here you can see our factory operator, Bob. Bob can nowadays buy machines that are equipped with the various interfaces, including field bus systems, OPC UA, and of course, OPC UA companion specifications, and so on. Some of these machines already come with a digital twin, in which, in our example here, the robot metadata are available in a standardized form. One example for the asset is the asset administration shell, which can be used as a digital twin. So Bob has now bought a robot that has these interfaces and digital twin, and he wants to use the predictive maintenance software from EMMA. So this is our EMMA here, and EMMA is a software provider. So first of all, Bob has to sign a contract with EMMA. Both are part of a federated data space that provides central services such as identity provider, a data catalog, and a clearinghouse. EMMA software wants to create a maintenance plan for Bob's robot. So to do this, they use the so-called connectors, which which act as link to the data room, and EMMA's connector retrieves the connection data from Bob via the identity provider, and the data catalog established the connection to Bob's connector. Then an initial REST connection, for example, is made via the connector to retrieve the information from the digital twin. For example, what kind or what type of machine is it, and which interface is available, and so on. As soon as this information is available, an OPC UA connection can be established for near real-time communication between the connectors, and EMMA can now retrieve the robot's operating data in near real-time to create a maintenance plan. This plan is stored then in the digital twin via the first connection, so that Bob can find the plan where all the other relevant documents and manuals are stored. In this example here, EMMA has communicated directly with the robot. Alternatively, Bob's connector could also point to an aggregation server that brings together data from the entire production line. UMATI's role in the future of the industry is UMATI will play a key role to establishing and further developing of the connector. UMATI already provides a gateway product that can be used to read OPC UA data, and this concept will be extended to develop a connector capable of transferring OPC UA data and integrating access control mechanisms. This connector will provide access control to the data space, which means that the access control of OPC UA server will remain relevant, and both systems will work in tandem in this case. The basic functionality of the connector makes it possible to define precise access rights from the outside. Through these developments, UMATI will help to further improve interoperability and efficient data exchange in the industry by providing a flexible and secure infrastructure for the federated data space. In long term, UMATI aims to create a fully connected industrial landscape that fosters innovation and competitiveness. So then we will come to Manufacturing X, where we are today. So the current state of Manufacturing X shows that we are in the development phase. Numerous technologies and concepts are being developed to drive the integration and interoperability of production systems and IT structures. Existing systems and protocols such as OPC UA and IDS data rooms provide a solid foundation for further innovations. However, there are still some challenges and shortcomings that need to be addressed to ensure a seamless and efficient implementation of Manufacturing X. So these challenges concern technical aspects as well as the further development and standardization of communication and data management solutions. Key feature of the demonstrator. So the demonstrator shows the entire communication chain from the shop floor to the software application and demonstrates the use of production machines at 2 different locations. The data transfer there is implemented via an IDS data room and standardized semantic models of OPC UA. This illustrates a practical thing that advantage of such an infrastructure, particularly with regard to interoperability and secure data exchange. So the use of semantic models enables a uniform and consistent interpretation of the data, which in turn increases the efficiency and the accuracy of the applications. The use of production machines at different locations also demonstrates the flexibility and scalability of the system. So the demonstrator that we have developed together with T-Systems already shows what is possible today and which deficits still need to remediate. It enables a continuous communication chain from the shop floor to the software application within a federated data room. Production data from machines at different locations can be recorded and transported via the IDS data rooms, and semantic models that already exist are used and provide a standardized basis for data exchange. So this demonstration shows that the basic technology and concepts are functional, but also the improvements are still need to achieve a fully integrated and optimized solution. Especially in the next 2.5 years, projects like Factory X need to work on these shortcomings to fully realize the vision of Manufacturing X. The demonstrator uses OPC UA for machinery and OPC UA for machine tools. There is a machine tool located in Aachen and another one in the Schunk factory. The data from these machines are read out and forwarded to an EDC, an edge data connector, via a classic gateway, which in principle acts as a connector. An UMATI gateway and EDC work together to transfer the data via the data room with the data catalog to the EDC at the WZL in Aachen. So predictive maintenance is carried out there with the data from the machine tools being evaluated, even though they are physically located at other sites. The tool management from WZL takes over condition monitoring and detection of wear. This setup demonstrates the ability to collect centrally, evaluate machine data across different locations, which significantly improves the maintenance and optimization of a production process. T-System provides the EDCs and ensure data transfer authentication based on the IDS standards. That's also very important. This ensures the secure and reliable transfer of data between the various sites and the central analysis center in this case. Compliance with the IDS standard guarantees that data integrity and security are maintained at the highest level, which is particularly important when sensitive production data are transferred, for example. The UMATI gateway is from UMATI and plays a central role here in the demonstrator. It acts as an interface between the machines and the EDC and enables secure and standardized data exchange. This integration of the UMATI gateway ensures interoperability between different machines and systems, which increase then the efficiency and flexibility of the entire system. The machine tools are used here in the demonstrator are crucial for demonstrating the practical again. So we need that to run the complete system. So these machines are located at different sites, and their data is analyzed centrally, which illustrates the power and benefits of a federated data room. The ability to aggregate and analyze machine data from different sources is the key aspect for optimizing your production process here. So the connector, which is used here in the demonstrator as shown, is currently still part of a living lab. That means that the demonstrator will only work in conjunction with the living lab. In the future, however, the UMATI gateway will be given its own connector, probably the EDC, I don't know, in order to offer a completely independent and scalable solution. This further development is crucial for the board implementation and use of the technologies in the real industrial environment. Yeah, then we come to conclusion where we are. So the development and demonstrations today show that OPC UA is an established solution for the shop floor, and that OPC UA companion specification provides semantic models for machine interfaces. UMATI is an initiative, and data spaces as the basis for data ecosystems are central building blocks of the future industrial landscape. So technologies such as an EDC could be used to establish user in the data space and further increase interoperability and efficiency. Yeah, this is where we are going to. In the future, IT and OT are expected to coverage more and more. It should be possible to use shop floor data directly from the data spaces to implement predictive maintenance and other data-driven applications. The vision is that data spaces makes it possible to ensure data sovereignty and data sharing at the same time. So UMATI plans to develop a starter kit with a connector that can make existing OPC UA applications data space ready, and this will enable the benefits of data space to be used in wide range of applications and further advance the digitalization of industry. In summary, the progress and demonstration today shows that the technologies and concepts for manufacturing are available and can implement it in some case, but only in some case. The next steps includes the further development and optimization of these solutions in order to create a fully integrated and efficient Industry 4.0 landscape. The coverage of IT and OT, the use of data spaces, and the guarantee of data sovereignty are key objects that are being driven forward by initiatives such as UMATI and also projects like Factory X and Manufacturing X. Okay, so thank you for your attention, and then I will hand over back to Heiko.